So in this video, continuing on the theme of logarithms and exponentials, we'll be focusing on how to plot graphs when x is a power. Now, when you are asked to sketch a graph, they are not looking for a beautifully and accurately drawn diagram. It should be relatively quick and using either common knowledge or certain properties and/or previously calculated answers or values from earlier questions. Now, when sketching a graph, you should focus on two main points. The first one is the shape of the graph, and the second is where it crosses the x and or the y axis. Now, note that labeling the axes and use of a ruler shouldn't need to be emphasized, more expected. Now, if you have a graphic calculator, then you really don't need to continue watching this video. Simply learn how to use it to plot the equation and find values at certain required points. And it's just a case of just copying off the screen, identifying where it crosses at certain axes and marking those and labeling. Now, in mathematics, it is important to have an idea of what things look like before we actually do it. Now, the same thing applies to plotting equations. By looking at an equation, it's about picking out key aspects to help give us an idea of what it actually looks like. So, for example, you can see we've got 5 examples of certain graphs. So, looking at the first one, we can see that by looking at the powers and what's contained in this particular equation, so I've got a single x and a single y, which basically means that this is going to be a diagonal line. It's going to be a diagonal linear line. Now I can also see that because my x is positive, that it's going to have a positive gradient. So therefore it's going to be going in an upwards direction. I also know that it's going to cross the y-axis at minus 5/6. So without even drawing it, I've already found certain aspects that when I do my sketch, as long as it abides by those kind of things that I've mentioned there, then it's a good chance that I'm going to get full marks for my sketch. Now moving on to the next one. So here we've got y equals 10 minus 2x squared. Well, I can see that here, because I've got a negative x squared, it's going to be a negative parabola. And so it's going to be like a N shape or a sad face. And I also know that it's going to cross the y-axis at positive 10. Because again, all I need to do there to work out the x-intercept, y-intercept, all I need to do is make x equal to 0. To work out the y-intercept, I just got to make x equal to 0 and job done, and vice versa. Right, so moving on to the next one. So here I can see that my highest power of x is a 3, so it's going to be a cubic graph. And it's going to be what we call an S shape. So it's going to look something like that. Now, in terms of where it crosses the y-axis, so it crosses the y-axis, two words, is going to be at positive 6. And then moving on to the next one of sine x. Well, again, I know that from my diagram, it's going to look something like this. And again, obviously, if things are being, what you need to do is when things are being added or subtracted to a particular equation, it then moves into graph transformation, which is a different topic that is unique to this one. But hopefully you would have done that before looking at log graphs to understand what type of thing it does in terms of translating it, stretching it, and moving it all over the place. Now, moving on to the last example here, we know that this is what we call a reciprocal graph. So we know that from the set of axes, it's going to look something like this, because obviously the one value that x can't be is 0. So obviously it's going to be asymptotic to that particular value. And again, whenever you are doing your sketches, always make sure that you are labeling your axes and generally using a ruler for your axes. Now, when it comes to plotting equations where x is a positive power, so for example, here we've got y equals 8x. Now, as mentioned, when sketching graphs, you just need to focus on where the equation crosses the axes, if any, and the shape as x tends towards minus infinity and positive infinity. So if we just look at this, if you're not too sure what I mean by positive infinity, so as x goes towards the right direction, and what happens when x goes towards the left direction. Now, when you are plotting an equation, let's just start off with something relatively quite simple. So let's start off with y equals 2 to the x. Now, from this, what we want to do is we want to see what happens where it crosses the y-axis. So to find out where it crosses the y-axis, so to find the y-intercept, all you need to do is make x equal 0. Now if I make x equal 0 in this, then what's going to happen is I end up with y equals 2 to the power of 0, and anything to the power of 0 is 1. So I'm going to imagine that 1 is there. I'm going to go from there. Now from this I know it's going to cross at this particular point here. Now the next thing I then need to do is then find out what happens as x increases. Well, if x increases, so let's just put some random numbers. So let's go for, now some good points are writing where x equals 1. So if you were going to do a table of values, then I strongly recommend that you could probably go for 5 values, which is not, again, what I'm saying here is not really essential. But I certainly would have to have a vague idea. You want some positive values and some negative values, and from there you can kind of get an idea of what it's going to look like. Now you don't need to go to the extremes of having, let's say, 10 or minus 10 or 100 or minus 100 or 10,000 or 10 million, because generally speaking the general shape of a log graph, or where x is a power, is generally going to be a familiar shape. So just like you know what a parabola looks like, or a negative parabola, what a cubic graph looks like, just by looking at it, hopefully you'll get some concept of what this type of graph actually looks like. So we know that when x is 0, y is going to equal 1 in this particular example. Now when I've got 2 to the power of 1, then that's just going to be whatever the base value is going to be. So if I imagine that 1 is here, then 2 is going to be, well, if that's 1, 2 is going to be about there. Now when I do y, so that equals 2. When I do 2 squared, that's going to equal 4. So you can see that as x increases, my answer is just going to get bigger and bigger and bigger and bigger. So what's going to happen, it's going to kind of curve in this direction. Now when it starts going into negative, so here when if I had y equals 2 to the power of minus 1, well, a negative power just turns it to reciprocal, so that's going to be 2 to the power 1, which is just going to be a half. So what's going to happen is as x becomes negative, and as that increases, so y equals 2 to the minus 2, so that's going to be y equals a quarter, and what's going to happen, it's just going to get smaller and smaller and smaller and smaller. Now it's not actually going to cross the 0 because this can never be negative. So what the graph's actually going to look like is something that looks vaguely similar to this. So it's actually going to be a curved shape, and like I said, the key points that you want to do when you're drawing these curves is making a note of where it crosses the y-axis, and generally speaking what's the value going to be at 1 and minus 1, and that'll kind of give you a vague idea as to what it is. Now if you do have any variations of y equals, so for example y equals let's say 3x, or what happens there, or y equals let's say an eighth x. So for example, if your base changes, we'll have a look at what actually impacts on that. But however, if you've got something like y equals minus to the 2x, so as a power, or y equals 2x plus 6, then again, like I said, that then moves into graph transformation. So where you start with the initial graph, and then you need to then perform the graph transformations to see where things have either been translated or been stretched parallel to a certain set of axes. So let's have a look at what happens when the base number increases. So we've looked at the general shape of when x is a power. It's basically going to be like a curve that crosses the y-axis only, so it never crosses the x-axis unless you're subtracting the equation by something to move to translate it downwards, in which it would cross both of the axes. However, generally, if you're not adding or subtracting anything, it's just going to be crossing the y-axis and asymptote to the x-axis. So let's have a look at what happens with the base number. So for example, I'm just going to use this piece of software to plot our equation. So let's go for y equals 2 to the x and have a look at that graph. So that's, as we've predicted, is going to be there. So here we can see that it crosses the y-axis at 1, and also that it goes through a particular point of 1, 2 as a coordinate. So what I'm now going to do is let's just label this coordinate. Or this graph, should I say. So that is y equals 2 to the x. So now let's have a look at what happens if the base number increases. So let's go for, and hopefully this is going to allow me to do it. Yeah, so y equals 3 to the x. So you can see that now it's getting closer and closer. So it's still intercepting the point of 1, 0, 1. So it still crosses at the same point of 0, 1. And at 1, it's crossing at 3. So if I just change the color, so the equation of this blue line is going to be y equals 3 to the x. So let's now have a look if we use a bigger base number. So let's go for, and again, just bear with me. So here, let's go for y equals 4 to the power of x. So you can see here it's just getting closer and closer. Now again, the key points there is that with this particular new equation of y equals, and let's just change the color. So with this purple line, what we've got is y equals 4 to the x. Actually, let's go for a different color because it's not that clear. Let's go black. So here we've got y equals 4 to the x. And that also crosses at 0, 1, because anything to the power of 0 is just going to equal 1. So that's why there's some familiarity between all the equations that we've done so far. And at 1, it crosses at, it goes through the point of 1, 4. So when x is 1, y equals 4. And again, because anything to the power of it's to 1 is just going to be equal to itself in terms of the base number. So as you can see, so as x increases, so as the base number increases, the y-intercept stays the same. However, the curve gets closer to the y-axis. Now, when would this appear on a particular exam? It might ask you, so for example, it might ask you, give you a set of axes, and then it might ask you to, it might plot one equation of, let's say, y equals, let's say, 3x, and then a question might ask you to sketch y equals 5 to the x. And so then you would then need to compare what the graph would look like. So for example, here, it's going to go through the exact same y-intercept. However, all that's going to happen is that it's just going to curve. It's going to be a lot steeper. The gradient's going to be a lot steeper compared to that equation. So that would be y to the 5x. And that's all they're looking for. It's just a sketch. It's not a case of measuring how close it's going to be to the y-axis. It's all about where is it in comparison to the actual sketch of what they've done of y equals 3 to the x. So before we move on to, let's have a look at what happens when we've got a small or a fractional base number. Let's just delete all the ones that we've done previously so we're not getting confused. And let me just relabel our initial equation. So this was y equals 2 to the x. Now, obviously, I'm not going to plot y equals 1 to the x because anything to the power where the base number is 1, it's just going to equal 1 regardless of what it is. So let's have a look at what happens when we've got y equals, let's say, 0.5 to the x, or how it's another way of writing it is a half to the x. So you'd think that, as we've talked about, so as the base number increases, it tends towards this direction. So your common sense is thinking, well, as x gets smaller, it's going to head in this direction. But let's actually have a look at what it actually does. So let me just quickly get rid of all of this, and we'll have a look at what the actual graph looks like. So let's plot y equals 0.5 to the power of x, and you can see that it's completely reflected along the y-axis. Now you might be thinking, that's a bit of a surprise, but yes, it is, because you think, well, as the base number gets smaller, that's what you get. However, when the base number is less than 1, so let's just write a little note. So when the base number is less than 1, well, basically what happens is if we had y equals a half to the power of 1, well, that therefore means that at 1, it's going to be at a half, which is where it crosses there. If I then had y to the half, y equals half squared, well, that's going to be a quarter. So it's going to be there. And then obviously, as the power increases, towards infinity, it's just the number's just going to get smaller and smaller and smaller, and what's going to happen, it's just going to tend towards 0. So this is kind of using a bit of common sense to expect what you get. Now obviously when x starts getting negative, so let's say I had to the -1, well then that's just the reciprocal of a fraction, which then you flip the fraction and it then becomes 2. So actually, as x becomes more negative, or a much smaller number becoming negative, then you'll see that the answer is actually going to get much bigger as you go on. So for example, y equals a half to the -2. Well, that's a half to -2, a quarter, sorry, a half, I'm just giving away the answer. Another way of writing that is a half, and that then becomes a quarter to the -1, squaring both numbers, which then flips a fraction to then become y equals 4. And that's where we get, when x is -2, y is going to equal 4. So it's kind of getting an idea and having an idea of what it should look like. Now you don't need to do a massive wealth of x values. I would generally go for -2 to +2, and you'll get a vague idea of what your graph should look like. So now let's move on to plotting equations where x is a negative power. Now, as mentioned, when sketching graphs, we just need to focus on where the equation crosses the axes, if any, and this general shape as x towards -infinity and +infinity. So again, let's just take an example of an equation. So let's say we've got y equals 2 to the power of -x. Now, as I said, the first thing you want to do is establish where does this cross the y-axis. So it crosses the y-axis when x equals 0. So what I've got is I've got y equals 2 to the power of -0, which doesn't really apply, it's just basically 2 to the power of 0. So here at 0, it's going to cross at 1. So that's going to be exactly the same. Now, moving on from that, if we then have the equation, let's say we're going to start with, and as I always said, so let's start with 1. So when x equals +1, then I end up with 2 to the power of -1, which, understanding the rules of indices, is a half. So then at 1, it's going to be a half. Then when x equals 2, then I'm going to end up with y equals 2 to the power of -2, which is 1 over 2 squared, which is a quarter. And so at 2, it's going to be half of that value. Now, as x increases, or as x tends towards infinity, all that's going to happen is the number is just going to get smaller and smaller and smaller and smaller and smaller, and just become asymptotic to the x-axis. It's never going to become 0, but it will generally get very, very close, where it's basically approximately 0. So let's have a look at the negative numbers. So what happens on this side? So let's say when x equals -1, so then what I end up with is 2 to the power of -1. Well, that becomes 2 to the power of +1, which then becomes 2. So at -1, it's going to be at 2. Then when x is -2, then I end up with y equals 2 to the power of -2, which is 2 squared, which is 4. So you can see there that as x decreases going into the negative, it's actually, the numbers are just going to get bigger and bigger and bigger. And what this graph then becomes is basically just like you would have learnt in graph transformations. When you're changing the sign of x, then all you are doing is you are reflecting the graph along the y-axis. So basically, when you've got negative power, your graph will generally look in that type of shape. So again, let's have a look at what happens when the base number increases, and see if the relationship is exactly the same as when we had positive powers of x, in which that the curve gets closer and closer to the y-axis, but the y-intercept remains the same. So first of all, let's plot our y equals 2 to the power of -x. And so as you can see, we get a very, very similar graph. And if we start plotting the sort of aspects of what we need to make sure that we're doing, so again, always make sure that your graph point, the shape of your graph, is exactly what it needs to. And then in your sketch, the only thing you then need to do is just identify where it crosses. So again, making sure you're noting where 1 is, and obviously just plotting those particular points would be absolutely fine. So let's just label this as y equals 2 to the power of minus x. So again, now let's have a look at what happens when we plot when the base number increases. So again, let's add this up. So we've got y equals 3, let's say, to the power of minus x. And you can see here that with this equation, it's doing exactly what it did with positive powers, in the fact that as the base number increases, it's just going to get closer and closer to the y-axis. So what we'll do, there we go. So this equation here is y equals 3 to the power of minus x. So as the base number increases, the curve gets closer to the y-axis. So again, you would expect y equals 5 to the power of minus x to be closer than 3 to the x, and again crossing at a similar value, and where this point here would be at a fifth. At a fifth. Now, the next thing we move on to is what happens if your base number then goes below 0. So as we said, it flipped it in the previous example when we had positive powers. So let's have a look at what actually happens with this. So let's just get rid of the blue equation. And let's have a look at what happens with this then. So here we've got y equals 0.5 to the power of minus x. And you can see it's then gone on to reflect it. So here what we've got is y equals 0.5 to the power of minus x. So you can see that when your value is less than 1, your base number is less than 1, it's then reflected back. So you could see here that actually y equals 0.5 of minus x is actually the same graph as y equals 2 to the power of positive x. Now again, if you're not too sure about how that happens, well, it kind of works when you look at actual values. So if I look at y equals 0.5 to the minus x, well, when y equals, well, when x equals 1, I should say. So when x equals 1, then what I've got is I've got y equals a half to the power of minus 1, which is then the reciprocal of that, which then becomes 2. Now again, when I had y equals 2 to the x, when x equals 1, then it gives me the exact same value, which is why they are the exact same graph. So it's just a case of, if you haven't got access to a graphic calculator, just picking a few certain values to get a general shape, and it's just a case of practice. Just like in terms of how you learned that parabolas, negative and positive parabolas, and cubic graphs and positive and negative, and reciprocal graphs, these are just another set of graphs that you kind of need to understand the shape, but to then compare it and draw it relatively and more accurate with identifying certain points, then all you need to do is just a table of values, quick and easy, job done. Now these questions are usually worth about 2 marks in an exam, so if you can try and get this question done in about 2 minutes, then that quantifies all the necessary work that you may be doing to get your sketch. Now we'll be having some questions, practice questions in the description below for you to practice sketching, and I'll also include the answers to what your graph should look like. However, you can always, like I said, go on to some graphical software. There are some really good ones free on the internet, or if you've got access to a graphic calculator, whether it be at home or at school, then just mess around with different graphs, change the variables, change the base numbers, start adding things to powers, start adding things to the equation. But again, this topic is very, very closely linked to graph transformations. So when you start adding things to the equation, when you start adding things to the x, or manipulating the x, or manipulating the original equation, it then really goes into graph transformations rather than creating new shapes of graphs or things that you kind of need to incorporate. Now, the one thing that's probably worth noting is what happens when you have, let's say, 2 to the power of 2x, and you're asked to sketch something that looks like this. Now, one thing that you kind of need to be aware of is that you can actually split this equation into 2 parts. So you can split this up as 2 to the power of 2 times 2 to the power of x. Now we've already looked at plotting this of 2 to the power x, and the question is, well, what we end up with if we simplify it is 4 times 2 to the power of x. Now from this, what this then becomes, as we're multiplying something to our, let's say, original function of this, in which the graph is going to look something like that, where it equals 1, and at 1 that's going to equal 2, let's say, and obviously labeling the axes. Then what you then need to do is look at graph transformation. So here what we're doing is we're multiplying the function, which is y equals 2 to the x, by 8. So here what's happening is that's then going to be a stretch parallel to the y-axis at a scale factor of 4. So here it's going to be, and actually that should know I put 8 there, that should be a 4. And there we go. So it's just a case of manipulating the equation to get it to what you're actually doing. And the key thing to remember, like I said, is if you do end up with something complex, just remember the basics. Okay, you're just looking for the general shape. You're looking at where it crosses the y-axis, and to try and get some idea of whether the curve is going to be on where it's going to sort of have a positive gradient, it's going to have on the left hand side or on the right hand side, or negative gradient. Then all you've got to do is just substitute a couple easy values that are close to the origin, and you'll get some general idea of what your shape should look like. Your backup should always be a table of values. Now one thing you can do on your calculator to help you decide on when it comes to these types of equations is to go on and plot an equation by using your table function. So if you can't be bothered to actually write down a table of values, then you can use your table function on your calculator. So most of you will have the Casio 991EX calculator. So if I just go on to the table function, and there it is. And then all I then need to do is just type in the function. So for example, f of x, just treat that as y. So if I had 2 to the power of, let's say, 2 times 3 to the power of x, press equals, and then don't worry about that. And then let's say I had some starting values of, let's say, minus 3, and I go to the positive values of, let's say, positive 3. I'm going to go steps of 1, that's fine. And you can see that that's now giving me some coordinates for me to plot. Now you don't have to plot accurately. All you're looking for is, okay, where do I start? Do I start high? Do I start low? And then where do I end? Do I end high, end low? And you can go from there in terms of your sketching. And again, with practice, you'll get a vague idea. And as I said, the key point, and again, I've said this about 3 million times already, or exponentially, excuse the pun, but is where it crosses the y-axis and the shape. And so once you've done that, you're going to be absolutely fine. Now we'll include some practice questions in the description below for you to practice these, and obviously you can check your answers by either using graphical software, or if you've got access to a graphic calculator, again, it's a no-brainer, just use it. Just type in your equation, sketch it, and job done. It'll do these questions. That's one of the biggest advantages of having a graphic calculator, is the fact that it can plot graphs for it. So obviously you can use it. Is it worth the extra money from a standard scientific calculator that's recommended for A-level to a graphic calculator? That's entirely up to you. Once you've mastered what graphs look like and what generally questions are going to involve, again, it's up to you whether you decide to spend that extra expense. But generally speaking, it's just common knowledge, and you can go from there. It just makes your life a little bit easier. You can get a vague idea of what your answers should look like. But again, there's no expectancy for you to own a graphic calculator.